Very good evening, all of you. So, as all of you know, that today we will be studying 3JS. And some of you, good evening. So, some of you might be knowing why do we use 3JS. If anyone has any kind of idea, then you people can switch your mic on and tell me why do we use the 3JS.
It creates a 3D world. Hello.
Yes, Chandu, can you please repeat?
Creating 3D graphs.
A container for all objects and defines the viewpoint, and also it renders the scene.
Okay, all right. So,
For
3JS.
representing three-dimensional
It's a JavaScript library.
3D graphics and animations in the web browsers.
Yes, Navya. All right. You people can switch your mic off now. So before proceeding with our session, what I want you people to do is that at this stage of the internship, I can expect from you people that you people will be able to create a React app, and you people might be remembering the command to create the React app as well as install these dependencies that I'll be showing to you. Install these dependencies because we will need these dependencies while writing our code. So please do create a React app and then install these dependencies. And then create a folder that is components and place a file that is 3scene.jsx inside the components folder. Just do it fast and let me know. Like, let me provide you the dependencies in the chat box. Do it fast and let me know how many of you have completed. And then we will proceed with our code. Yes, Prasan, are you having any kind of doubt?
Hello.
Yes, Miss.
Hello. Actually, ma'am, I have doubt about previous presentation. I mean, the project we had to present. Ma'am, at first, in first project review, I didn't have the access to join, but I tried to join in time, ma'am, but they didn't let me in. So, and my attendance, ma'am, I had joined all the meetings, but my attendance is only 4. So I wanted to talk about it.
So, Mosam, regarding the project review, you might have been joined late back then, dear, because on 8 o'clock sharp, the attendance is closed for everyone. So, you had to join before 8 o'clock.
Ma'am, what about attendance? I had joined all the lectures.
Mosam, do one thing, just email the support team and they will help you to resolve your issue.
And ma'am, I had screenshot about in first project review. I had joined before the time, and I had screenshot also, ma'am, and I had sent it to um, Infotact solution WhatsApp group, ma'am, to a teacher. Yeah.
Did you write it to the support team regarding that?
Yeah, I had, but sir said that you can present your review in next project review.
Okay, then when we will take the next project review, at that time we will take your previous project review. Okay.
Yes, ma'am, that's okay. But about my attendance, they have only shown 4. I mean, I had attended all, but they are showing only 4 attendance. So, and my
Okay,
project mates and group mates, they already had quit.
all right. The support team will contact you regarding your issue.
Okay, ma'am.
All right. So did you did the task that I have provided to you, people? Creating the component folder and installing all the dependencies that I have provided to you? Everyone?
Yes, ma'am.
Okay. So let's proceed with our code now. And I'll go to the 3scene.jsx, and over here I have to import some of the hooks as well as some of the features as well as functionalities and the utility classes from different dependencies as well as files. Firstly, I will import the hooks, which are firstly I will import React, and then I will import use effect, and then in order to use 3JS elements, the another hook that we require is use ref, because it will provide us the reference of all the components that we are providing inside our web page to render in our web page. Got it? From React. After that, I'll import everything. For everything, I will use asterisk as three from 3. So if I want to access any element of the three dependency, what I will use? I will use the 3 as uppercase. And then I'll also import orbit controls. And when we will use it, I will tell you people why do we use this orbit controls. So, examples, JSON, controls, And from the controls, I will get the orbit controls. That is for the JavaScript. After that, I will also import GLTF loader. Loader. The same file directory, that is 3, and then examples, JSON, loaders, and from the loader I will get GLTF. After importing this, I will also import each and everything from the canon. And we use this canon for providing some of the concepts related to physics in our project, such as gravity, etc. So here we have installed all our dependencies as well as functions that we require in order to make our Three.js project. Firstly, what I will do, I will create a function that is const 3c, which will be an arrow function. And inside that, I will declare a variable that is const mount ref. And over here, I will use the hook that is use ref. And inside that, I will provide null because I am initiating the variable as null. After that, I will provide another hook that is use effect. And inside this use effect, I will write some of my functionalities. And this is the main hook within which the exact code, or you may also say all the logic regarding to my project will be present inside this use effect. So firstly, if not mount ref dot current return. So what does this mean? This means that if the see, we will be creating a div tag for mounting our main logic or our objects inside our web page. So at first it will check whether the div tag is present or not. For that purpose, we have provided if not mount ref.current, then it will return nothing. Else, what we will do? We will create a scene. So for that, for your convenience, let me write create scene. So we will store this scene in the const scene variable is equal to new. And in order to create a scene, we will use 3.scene. 3.scene. So when I'll ask you people like why do we use the scene function, then you have to say that we use the scene function in order to create a scene inside the to create a scene for our website. So this is the very first thing that we do in order to create our Three.js website. After that, the second thing that we have to do after creating the scene is we have to create camera. After the camera, we will store const camera is equal to new 3 dot perspective camera. Now you will ask, ma'am, what is the main function of this perspective camera? So, what does the actual camera do? Inside the actual camera, we see the objects that are placed far away from us, right? So over here as well, using the perspective camera function, the objects farther away appear small, just like we see in the real life, right? So this is the very function of perspective camera. And you will discover many things over here that resemble in real life. So if you want this code and for your convenience, I will also mention that perspective camera makes us see the object appear smaller when they are far away. Inside this perspective camera, we will be having some of the parameters. And what kind of parameters are they going to be? So inside the perspective camera, you will have firstly the field of view. And now you will ask me, ma'am, what is field of view? So say if you provide 50, right? So you will get a width. And then if I increase it, then you will get a larger width. So the much you will increase the field of view, the much wider you will be able to see from the camera. That's how this perspective camera works. So this is my field of view. Field of view. That is FOV. You can also say that the higher the FOV, the wider you'll be able to see. And second parameter will be our aspect ratio. And I guess I don't need to tell you people about the aspect ratio. Can somebody tell me what is aspect ratio?
About the screen size. Is it
Yeah.
a square, rectangle, like that?
Yeah. So in order to provide the aspect ratio, what we have to write? We will write window dot inner width divided by window dot inner height. So this is how we calculate our aspect ratio. That is window dot inner width and then divided by window dot inner height. After that, we will have our near as well as far. That how near is our distance is going to be and how far the distance is going to be from our eyes. So for the near distance, I will provide 0.1, and for the far distance, I'll provide 1000. So if I'll ask you people what kind of parameters do we have inside our perspective camera, then you have to say we will have our field of view and then the aspect ratio as well as the near length and finally the farthest length. Am I clear till here?
Yeah.
Okay. All right. So up till here, we have created our perspective camera. And after making our camera, the next thing that we do is we will provide a position for our camera. That is camera dot position dot set 0, 2, 5. So as you people know that we create 3D models using 3JS, isn't it? So whenever we are working with 3D figures, what do we have? We have three kind of planes. That is the x-axis, the y-axis, as well as the z-axis, right? So in the the value for the x-axis 0, and for the y-axis is 2, and for the z-axis is 5. So these are the coordinates where our camera's position is going to be. And after creating our camera, what we will do? We will render our camera. So the third thing that you have to do is create renderer. And what do we use in order to create the renderer? We will use the WebGL renderer. Const renderer is equal to new 3 dot WebGL renderer. And you will ask me, ma'am, for what does this GL stands? This GL stands for the graphics library. Over there only we are able to create 3D models. And inside this, I will use anti-alias. And now you people not be knowing what the anti-alias are. So whenever we make any object inside our web page, the work of this anti-alias is to smooth out the jagged edges in 3D object. It makes the edges look very smoother. Instead of appearing them as very sharp, the anti-alias, what do? It makes them look very smooth. Or you can also say it makes them look very blunt. After providing this anti-alias object inside the WebGL renderer, and after we will set the size of that. For that, we will use renderer dot set size dot set size, and for this also we will use the window dot inner width, and then window dot inner height. So this will be placed inside the inner width as well as the inner height. What will be get placed? Whatever thing that we have made inside our this perspective camera, this will get the size of the window's inner width as well as window's inner height. Are you people getting my point?
Yeah.
So in order to make our 3D object look more realistic, we provided some kind of shadow. So in order to provide the shadow, I will use renderer let's make it small. So I will write renderer dot shadow map dot enable. I will enable the shadow map. For that, I will write true. After that, I will also use mount ref dot current append child renderer dot DOM element. So after writing this line, what will it happen? The DOM element will get rendered in the web page. For that, we are using the append child function. After that, what we have to do, we have to handle the window size. Handle window size. So for handling the window size, we will create another function, that is const handle size. And whenever the user will try to alter the size of the window, then this function will get called. So it will alter the camera dot aspect is equal to window dot inner width divided by window dot inner height. And it will alter the aspect ratio, and then it will update the aspect ratio of the window. So in order to update the aspect ratio, we have another function, that is update projection matrix. So we will use it as camera dot update projection matrix. And if we do not write this function, then whenever user will try to change the size of the window, it will not be able to happen, because we will not have been mentioning this update projection matrix. And then we will set the size again using renderer dot set size window dot inner width, and then window dot height. So this is what we have done. We have made our function in order to handle the size. After that, we will write window dot add event listener, and what it will do, it will call the resize function of the browser element. You might be remembering there is a function for the browser, right? That is resize. Whenever we call that function, the browser automatically gets resized. So when the resize function will be called, our handle size function will automatically get called. For the next thing, that is the fourth thing that you have to do, is what I will do, I will add lights in my web page. And how to add lights over here? We are having a function called ambient light. So we'll use it as const function name will be ambient light. Well, basically, this is the variable that will be storing the function. Ambient light is equal to new 3 dot ambient light. And inside this, I will provide the white color. And for the white color, the see, over here it is written 0x6f. 0x FFF.
I think you have to give it in the string format, I think so.
Yeah, I'll place it inside the string format. And after that, I will provide the intensity of my light. That is 0.5. And then I will add the light to my website. So for that, I will write scene dot add ambient light. And then I'll again create a point light. Const point light is equal to new key dot point light. And this also I will provide as white. 0x f, and the intensity is also going to be 1. After that, I'll add the position, that is point light dot position dot set, and I'll provide the coordinates as 10, 10, and 10. And then I will also make our point light to cast a shadow. For that, I will use point light dot cast shadow. It will be true. And for that, I will, in order to make it seen in our web page, I will write scene dot add point light. So this is what we have done. We first altered the size of our web page, then we created the size of then we also provide lighting to our web page. Also, what we have done, we added the perspective camera. So now what it will do, it will create an object which is going to perform some action in our web page. In order to create an object, which is basically, I'm going to create a cube over here. Create cube. I will write the variable name const texture loader is equal to new key dot, I will use the function texture loader, because these objects or 3D objects are created using the texture loader as well as geometry. Const texture is equal to texture loader dot load, and the load function will having four parameters. The first will be the URL, the second will be the on load, the third will be the on process, and the last will be on error. Got it? So in the URL, what do we have to mention? We have to provide the name of our PNG or SVG files that we have stored inside our public folder. So I have already stored a texture.png file in my public folder, as you can see in the screen. So inside the load function, I will write the file, the URL of my file. That is, what do I have? Texture, let's say cube.png. Cube.png. This is my URL. And then what I will write? My onload. That is, this function is going to, this is a callback function basically. Whenever the load will be called, this function is going to, this function will also be called. So for this, when this will load, I want my console to print console.log texture loaded successfully. So this is my second parameter. And in the third parameter, we will be having the on progress. So it will provide whichever thing is going on while the load is being processed. So for that, we will not mention anything over here. So we will provide undefined. And finally, the error. For providing the error, we will write error. And it will provide the error in the console. Dot error. And inside the error, what it will say? It will provide texture loading error. This is my first parameter, second parameter, third parameter, fourth parameter. Texture loading error.
I think you don't use the semicolon at the end of the error.
Actually, I have to provide one more bracket over here. After that, it will provide the error. So these are four of my parameters that will be placed inside the load function. And then I'll make another variable, that is const geometry.
Are you using it in the inside the texture?
Yeah.
But it
What?
was taking as in loading.
Just a second.
Yeah.
Const geometry. And this geometry will be used to create a box geometry. So basically what I was doing, I was creating a cube, right? So for that, I will use the box geometry. New 3 dot box geometry. And then I will write const material is equal to new 3 dot mesh standard material. So basically what we are doing is that we are making the shape as well as appearance of our app, of our object that we are going to place in our website. So for shape, we will use the geometry function, that is box geometry, and for the appearance, we are going to use the material. After that, we will use const q is equal to new 3 dot mesh, and this mesh function is going to combine the geometry as well as the material. After that, finally, what we will do, we will add this thing to our scene using the add function. The sixth thing that you have to do is load external 3D model. So this is what we have done. We have created a cube using the 3JS, right? And in order to use that cube, we also have to use the load the external 3D model using GLTF loader. So what this GLTF loader is? This GLTF stands for Graphic Library Format Format Texture. So the GLTF stands for Graphic Library Format Text Transmission Format. In order to use this, we will declare a variable that is const loader is equal to new GLTF loader. Using this variable loader dot load, and inside the load, I will again place my 4 parameters. First, the URL will be there, that is model dot GLTF, and then the function that will be called, that is having the parameter GLTF. First will be GLTF dot scene dot position dot set 0 0 minus 2. So these are my 3 axes, that is X, Y, and Z. So what it will do? It will make the object go backwards in the Z axis. Got it? So for that purpose, we have placed -2 over here in the position, that the position of the cube will be very backwards in the Z axis. After that, I'll make it to have some shadow. Dot cast shadow should be seen. Dot cast shadow. This will be true. I'll simply add it in the web page. This is my function, and the on load will be undefined, and finally there will be the error. It will print console. Inside the console, it will say GLTF load error. So these are my 4 parameters inside the load function. After that, I am providing the camera controls. So for the camera controls, I will use orbit controls. It's const controls is equal to new orbit controls. Inside that, the camera will be one of the parameters, and renderer dot DOM element will be another parameter. And this orbit controls does perform some of the tasks in the web page. Say for instance, if you zoom the web page, or you can use your mouse in order to do flip the object, or make some changes in the view of the object, like you people do in Flipkart, right? Flipkart provides you 3D view of the object. So for that purpose, we use this orbit controls. So in order to enable those functions to take place, what we have to do? We have to write controls dot enable zoom.
Spelling mistake here.
Say if we want to pan that, controls dot enable pan. It will also be true. After that, I will use some of the concepts of physics. It is gravity and all those things. It is physics. And for that, I will use canon.js. I made you import those canon and all those things and the dependencies. So we will use those things over here. And inside the web page, there will be a virtual world. And you people and all of you know that our world, that is the, I'll not say world, that our earth is having gravity. So over here as well, I'm going to add gravity as a feature. So firstly, I will create a world. Inside that, I will use the order to create a world. Canon dot world. And then I will use world dot gravity dot set 0 in the x-axis, -1 in the y-axis, and 0 in the z-axis. So from here, we are able to understand that in the y-axis, I have placed -1. What does it mean? My object will,
I go
yeah,
up, it
my
will come
object
down.
will fall down in the y-axis. And now here, I will create a physics body for my object. That is the cube. For that, I will write const cube body is equal to new canon dot body. The mass of the cube will be 5. So the more the mass, the less will be the speed, the shape. New canon dot box new canon dot 3. Since it is a 3D shape, so each and every dimension of that is going to be 0.5. And since it's a cube, see how simply we have created a world and also placed an object inside that world. So after that, I will set a initial position of the cube body. Cube body. Say position dot set. In the x-axis, I will provide 0. In the y-axis, I will provide 5. In the z-axis, I will provide 0. And then I will add it in the world. world dot add body set that cube body. And then I'll provide my animation to it. This is my animation loop. So whenever I will refresh my page, this loop will get executed and same thing will perform again and again. For that, I will provide a function that is const animate is equal to request animation frame. For adding any kind of animation, we will first use request animation frame function and place animate within that. And here we will update our physics. World dot step and you know what is this 1 by 120 mean? This means that in 1 second, it will update 120 times in 1 second. So in order to represent that, we are using 1 by 120. And then I will write cube dot position dot copy cube body dot position. And then I will also rotate the cube for effect. The cube. In the x-axis, I will rotate it. Dot rotate. In the x-axis. Or you can write rotation. Dot x. And for the, you can do the same thing for the y-axis as well. Cube dot rotation. Dot y. And then we will render it. Dot render. Scene and the camera. And finally, I will call this function that is animate. After that, I'll write the cleanup code. Return. We have to insert the animation. Will be outside it. Here is my cleanup code. Inside the cleanup code, we will return if mount ref dot current and renderer dot element dot DOM element. It will remove the child. Ref dot current dot remove child. Dot DOM element. And finally, this will remove all the remove event listener window dot remove event listener. Again, that it will resize it. Resize. Comma. Handle resize. Size. After that, we will place an empty array. And I told you previously, right, that we will be having a div tag inside the web page. So for that, we will write return. Set this red div, and the ref is equal to mount ref with style is equal to width 100 W, that is the complete screen width, and the height will be the complete view height, that is 380. And the div tag will be closed. And finally, we will export our default function. Default 3 scene. Save it. And for the app.jsx, you people already know that what do we have to do. Can somebody tell me one after one? Go on fast. You people know.
We have to import the 3c.js.
Exactly. And we have to mount it
We have
inside the.
to import it.
We have to mention it within the return function, right?
Yes.
Okay. So that is the thing I have done over here. Inside my app.js. See, inside the div tag, I have mounted my 3 scene function. Also, I have imported it over here. Now I will go to my terminal. CD. Hopefully, there shouldn't be any error. Okay. See, we are seeing a cube falling from the upwards, right?
Yes.
Let me show you people again. If I refresh the page, see. So it fell down as much as the width I have provided to it. See, the size is reducing it as it is going far. Right?
Yes.
Any doubts still here?
No.
All right. You people can leave the meeting if you people don't have any doubt.